All right, so let's look at question 8. Am I sharing my screen? Okay, let me check. Yeah, sure. Okay, in a textbook, there are 100 misprints distributed randomly and independently throughout the 400 pages. Okay, so first question, find the mean number of misprint per page. Okay, so question 8 is a Poisson questions. Okay, where you're given the total 100 of misprint spread over the 400 pages. So find the number of misprint. Okay, the mean number. Okay, so the mean number of misprint. Okay, per page. Okay, so basically this is finding the mean, the mu, or the lambda. Okay, so how to calculate the mean? You take 100 divided by 400, which means on average, they are 0.25 misprint per page. Okay, they are 0.25 misprint per page. Okay, so question 2. What is the probability that exactly 5 misprint in the next 5 pages? Okay, so for question 8, you will see different number of pages for different number of questions. All right. So for different number of pages, you will have to adjust the lambda accordingly. Yeah. Okay, so let's say for question 2, okay, the pages is 5. Okay, so what is the mean number of misprint in 5 pages? So the lambda will be equals to, okay, one page you expect to have 0.5 misprint. So you take 0.25 times 5. So you get 1.25 misprints per 5 pages. Okay, one page you on average you expect 0.25, so 5 pages you will get 1.25. So using lambda equals to 1.25, you'll find x equals to 5. So if you look at the statistical table, I don't think you will have 1.25. So what to do is you have to use the formulas to calculate the probability. X equals to 5. Okay, 5. So E negative lambda times lambda power x divided by x factorial. Okay, so your answer should get 0.0073. Okay, next questions. What is the probability that there will be 2 or more misprints in the next 6 pages? Okay, so first we find the new lambda, okay, because now we have 6 pages. So our new lambda, it will be 0.25 times 6. So the average number of misprint is 1.5 misprints, okay, per 6 pages. Okay, so you want to find probability x 2 or more. So 2 or more means at least 2. So more than or equals to 2. So again, you are not going to sum up from 2, 3, 4, 5 all the way up. Okay, you will take 1 minus the probability less than 2 because this is easier. Okay, you have lesser calculations also. So your minus x equals to 0, minus x equals to 1. Okay, So you check the statistical table. Do you have 1.5? Ah, you got 1.5. Okay, so just now 1.25 you don't have. 1.5 you have. So 1 minus x equals to 0 and 1, right? So you minus off these two probability. Okay, then you will get the answers ready, right? So 1 minus, oops. 1 minus 0.2231. That's 0.3347. So, okay, the answer is 0.4422. Yeah, got it. Okay, question 4. Question 4 is, okay, what is the probability there are less than 3 misprints in the next 12 pages? Okay, so you have to calculate a new lambda again. Okay, the new mean. Okay, one page average is 0.25. How about 12 pages? So you times 12. Okay, so times 12, you will have 3 misprints per 12 pages. Okay, what probability you want to find? Probability less than 3 misprint. So less than 3, that means 0, 1, and 2. Okay, 0, 1, and 2. And you check whether you can find it from the statistical tables or not. Okay, so this time we have 3, right? Okay, so we look at 3. Okay, you want to find x equals to 0, 1, and 2. So this is 3 probabilities lah, right? 0, 1, and 2. So you add up these 3 probabilities. Okay. So if you can't find it from a table, remember, okay, use the formulas. So final answer would get to 0.4232. Okay, question 5. Okay, question 5 is, what is the probability that there are more than 2 but less than 8 misprints in the next 12 pages? So this question is the same as the previous one. So we are still going to use lambda equals to 3. Okay, for 12 pages. Okay, so you want to find probability more than 2. Okay, the number of misprint is more than 2, but less than 8. So you add up all the numbers between 2 and 8. So you have 3, 4, 5, 6, and 7. Okay, 3, 4, 5, 6, 7. Total 5 probabilities. So again, this one you refer to the table, statistical table. Look at x equals to 3 to 7. Okay. So if you're calculating using the formulas, write your answers in 4 decimals. Okay, so this is the probability. So for 8. Okay, that's it. Any questions? So we have done binomial and binomial and Poisson distributions questions. Okay, now we'll move on to normal distributions. Okay, the chapter 6. Chapter 6 and 7, I think there are some questions involve 7. Yeah. Okay, are you guys ready? Can we move on to the next questions?
Yes.
Yes, huh? Okay, let me know if you are still copying, then I'll wait for you. If not, okay, if you don't want the whole class waiting for you, then you do the screenshot and then save the picture first, and then later on you copy the answers. Okay, so look at question 9. Okay, question 9 is a normal distributions questions. Okay, you have chocolate waffles. Factory manufactures chocolate waffles with a mean 100 grams and a standard deviations of 5 grams. Okay, assume that the weights are normally distributed. Okay, so how do I know this is normal distributions? Questions will tell you, okay, if the distributions is normal. Okay, what is the probability that a randomly selected waffles, okay, okay, first questions, with more than 95 grams, okay, 95 grams. So here, okay, so for normal distributions, we will, okay, to find the probability, we need to refer to the statistical table. So make sure you guys know how to read the tables. Okay, so for these questions, let me move this to the bottom so that we have more spaces. Okay, question 9. Okay, weight more than 95 grams. Okay, first, let's write down the informations that we have. Okay, let's say X is the weight of the waffles. Okay, so it follows mean is 100, standard deviations is 5. Okay, so X is normally distributed with mean hundreds. Okay, so when you are writing in this form, okay, we will write variance instead of standard deviations. So you need to square the standard deviations given. Huh? Okay, when we are writing in this format, okay, it's always mean and variance inside the brackets. So to find the probability for normal distributions, you need to convert to Z. Okay, the formulas that we use is X minus mean. Okay, X minus the mean divided by standard deviations. Okay, to convert the X value to Z. Okay, so Z is the standard normal distributions. Okay, standard normal distributions. Okay, where it follows normal distributions as well, but with mean equals to 0, variance is equals to 1. Okay, we want to convert to these standard normal distributions. Okay, so question 1. Okay, when you randomly select a waffles, what is the probability that the weight is, okay, the X, which is the weight, more than 95 grams? Okay, so X more than 95, you will convert it to Z. Okay, so you will take 95 minus the mean, 100, divided by the standard deviations, 5. Okay, so the answers that you get is Z more than -1. Okay, so I will normally suggest students to draw the normal curve. Okay, when we draw the standard normal curve, Okay, the middle is always the mean, which is 0. Okay, so this is the curve for standard normal distribution, Z, yeah? Okay, so right now you want to find Z more than -1. Negative, where is negative? Okay, left hand side is negative, right hand side is positive. So right now you got a -1. Okay, so -1, it will be to the left of the mean. Okay, but you want to find Z more than -1, meaning you want to find this area. Okay, this is the area. Okay, probability Z more than -1. Okay, so to find the probability, let's look at the statistical table. Okay, there are 2 pages for the standard normal table. Okay, the first page is when all your Z values, okay, your Z values are negative. Okay, and then you want to find, okay, the probability Z less than this negative value. Okay, let's say you want to find probability Z less than -2.61, for example. So you will look at the probability here, -2.6 for the first decimal. Second decimals, you will look at 0.01. Okay, so your probabilities will be this. Okay, 0.0045. Okay, so the areas that you look for is always to the left. So let's say if you want to find Z more than -2.61, okay, meaning the areas to the left, sorry, to the right. Okay, this is -2.61, right? Okay, but you want to find this area. So what you do is you take 1, the total probability is always 1, minus the area to the left. Okay, you minus the area to the left, which is this part. Okay, so you take 1 minus 0.0045, then you get the answers that you want. Okay, so the sign here is very important. Are you looking for less than or more than? Okay, so the area, the shaded areas that you want to find, okay, they are totally different. One is on the left, one is on the right. So you need to know how to read this table. Okay, this table is always telling you the areas to the left, to the left. Okay, so first page is negative value. Second page is positive value when your Z is positive. Okay, so again, let's say for example, you want to find the probability Z less than 0.58. Okay, so this refers to the area here, but Z is 0.58. So what you do is you, for first decimal, you look at the row. Okay, the first column 0.5. Second decimal, you look at 0.08. Okay, add up together, you get 0.58. So the probability is 0.7190. Okay, so if you want to find the opposite, okay, Z more than 0.58, okay, which is maybe this area. So you take 1 minus less than 0.58. So 1 minus 0.7190. Okay. So basically that's it, how we find the probability. So back to the question now. Okay, the questions that we want to find is Z more than -1. So we will have to refer to the first table. Okay, but because the area that we want to find is on the right side, so we have to take 1 minus areas on the left. Okay, so area on the left, this one, this part, which is this. Okay, you 1 minus the area on the left, then you can find the areas on the right side. So because it's negative, you move back to the first page. Look for -1. -1 is here. Okay. So probability is 0.1587. Okay, 1 minus 0.1587 will get you 0.8185. Okay, please get the idea clear on how to find the probability, yeah? Because for the remaining questions, I won't be showing you how to find the probability from the tables already. So if you don't understand, please let me know now. If not, the other remaining questions, I will just write down the probability. Okay, so I won't like come to this table, how to find it, then come back to, okay, you waste a lot of time already. Okay. So any questions about this? Okay. Okay. Second questions. Okay, the weights is between 95 and 110. Okay, so sometimes you may have the x value to be between two values, 95 and 110. So what you do is the same as the same first questions. Convert both to that value. So sometimes students doesn't want to write these steps. It's fine. Okay, if you don't write these steps, how to convert to z value. Okay, minus mean divided by standard deviations. Okay, you can straight away go to the second steps. Okay, you can straight away go to the second step. You write down the z values after your conversions. Okay, so you get -1 and 2. Okay, so the areas that you want to find now, okay, middle is always 0. You know, find between -1 and 2. Okay, between -1 and 2. So what you do is, okay, to find these shaded areas, okay, you take z less than 2. Okay, the area less than 2. Okay, then you minus the area less than -1. Okay, then you minus the area less than -1. Okay, minus of this. So the big area, the big shaded areas, okay, you minus the orange area, you will get the area between. Okay, so for this one, okay, z less than 2. Less than 2, 2 is a positive z value. So you refer to the second page. Look at 2.00. So the probability is 0.9772. Okay, 0.9772. Okay, less than -1. Okay, this is same as the first question system we found, 0.1587. Okay, so the final answers would be B. Sorry, just now 8185 is the answers for second questions. Okay, first question is not 8185. Okay, but this one is 8413. Nobody tell me. Okay, did you guys try the questions? I hope you know how to do it. Please do not tell me, oh, I don't know how to do. Oh my God, you're left 2 weeks only. If you know nothing about this, you better work harder already. Yeah, okay. Okay, question 3. Okay, let me know if you have any questions. If not, I will just keep moving, keep going on. Yeah, okay. Width between 105 and 115. Okay. So, but basically the idea is the same. You want to find x Okay, just different values only here. 105 and 115. Okay, so convert both to Z. Okay, so if I don't want to show the conversions, I can straight away write this. Okay, Z is between 1 and 3. Okay, you minus the mean, divide by the standard deviations, you will get 1 and 3. Okay, so here 1 and 3. Okay, so this is the area. Oh, sorry, wrong. Okay, wrong. But why? Because both are positive value. Okay, both are positive value because remember the middle is always 0 already. So 1 and 3 should be on the right side. Okay, so this is the area that you want to find. Okay, so what you do, okay, same like the previous questions, take the largest area, Z less than 3. Okay, less than 3, you minus Z less than 1. Okay, you minus less than 1. Then you will have the area in between here. Okay, you will have this area, right? Okay, need some imaginations. If you don't need the graph and you can solve it, then even better. Okay, good for you. Okay, then you don't draw the graph if you don't need it. So less than 3, okay, refer to the statistical table. So you have 0.9987. Less than 1, you will have 0.8413. Okay, so final answer, you will get 0.1574. Okay. So next questions, okay, similar questions, but between 85 and 95. Okay, 85 and 95. So idea is the same, convert both to Z value, both 85 and 95 to Z value. You will get -3 and -1. Okay, so please take note, whenever you solve probability questions, you will never get negative answer. Your answer will never be negative for probability. Okay, so if you get negative, then confirm is wrong. Okay, that means you have done something wrong lah. Okay, you should not have got a negative answer. Okay, -1 and -3. Okay, so same, take the area. Okay, the larger Z value would have the larger probabilities. Okay, so -3 and -1, which one is larger? -1 is larger. So take the larger probability. Okay, and then you minus the smaller probability. Okay, you minus of this. Okay, so refer to the statistical table. Less than -1. Just now we have actually found this. 0.1587. Then less than -3 is 0.00114, is it? Let's see. 0.0013, sorry. Okay, 13, yeah. Okay, so your final answer 0.574. Okay, so that's how we find the probability for normal distributions. Okay, question 5. Question 5 is applications questions where questions give you the percentage. You have to know how to find the X value. So if you see question 1 to question 4 is question tells you the X. Okay, all these are the X value. you need to find the probability. How if questions give you the probability? You need to find the x value. Okay, so this one a bit tough. Okay, as compared to finding the probability. Okay, so here you want to find what is the minimum weight of the heaviest 10% of the chocolate waffles. Okay, the minimum weight for the heaviest 10%. So we are talking about the weights of the waffles, right? We are looking at top 10%. Okay, the heaviest 10%. So let's illustrate this. Okay, let me draw it beside here. Okay, so remember x is the weight. X is the weight. So if I draw the distributions, the weight distributions, okay, the mean is given 100 grams, right? Okay, but if we are looking at the top 10%, the heaviest, okay, so to the right side, you will have more than hundreds. To the left, you have less than hundreds. So we are interested with the heaviest 10%. So definitely more than your mean already, right? So we are interested the area to the right, okay, the heaviest 10%. Okay, the heaviest 10%. We want to find what is the value, let's say A. Okay, A is the minimum weight. Okay, so let's say A is 130 grams. So the minimum weight for the top 10%, it will be 130 and above lah. Okay, the minimum is 130. So it could be 131, 132, and so on. Okay, we want to find this A value. Okay, so understand this already, we could write our first steps. Okay, our first working, x more than A is 10%, so equals to 0.1. So this is what we need to write. Okay, what we need to write. Then we convert to z. Z more than A minus the mean divided by the standard deviations equals to 0.1, which means if we convert this graph, okay, to z, okay, we convert it to z, what we have, okay, let's okay, so let's tally them. Okay, so the middle here, the mean is now equals to 0. How about the A? The A is converted to Z already. So minus the mean divided by standard deviations 5. How about the percentage? Should be the same, 10%. Okay. So to find this value, okay, at 10%, what is this Z value? What is this Z value? Okay, I'm not sure how do you learn it. Okay, so how I teach my student is I will refer, okay, I will refer to the T distributions table. Okay, so if you learn it the other way, another way from your lecturers, and you are comfortable with the methods, okay, yeah, you can stick with it, okay, as long as both methods will get you the same answer. Okay, they should get you the same answer. Okay, so my method is I will ask my students look at the T distributions table. Okay, T distributions table, go to the second page, okay, the last page, look at infinity. Okay, look at the degree of freedom. df is the degree of freedom. We look at infinity. Okay, so all these will be the z value. Okay, all this will be my z value. for different area, okay, for different areas. So you have the area 0.1 means 10%, 5%, 2.5, and so on. So depends on the area, you have different Z value. So meaning for the first one, if the area is 10%, okay, you know that it's 10%. So your Z value, okay, the Z value for this is 1.282. Okay, if let's say this one 2.326, where is the area? 0.01, okay, meaning 1%. So if you know that the area is, or the probability is 1%, so the Z value would be 2.326. Okay, so how about if the area is is on the left hand side, let's say if the area lies on the left, okay, 10%. How? Okay, the Z value would be a negative value. Same for this one. Okay, if we reflect it to the left hand side, the value will be a negative value. Okay, because remember the middle is always 0. So right side is positive, left hand side is negative. Okay, so right now our area is at the right side. Okay, at the right side, 10%. So what is our Z value? So our Z value for 10%, 0.1, it will be what's 1.282. Okay, so meaning this value is actually 1.282. Okay, or another words means Z more than 1.282 is 10%. Okay, then you compare the second and the third equations, these two values, they are the same, right? Okay, so A minus mean divided by standard deviations is actually your Z value, and your Z value is 1.282 for 10%. Okay, so you solve these equations, then you will get the A values really, which is the minimum weight. Okay, so minimum weight is 106.41 grams. Okay, so the minimum weight for the heaviest 10% is 106.41 grams. Okay, any questions? This one a bit tough. Okay, can you understand what I'm saying here?
Do we need for distribution estimates for each top?
Sorry, do you need what?
Uh, it means do we need for the estimates
You mean
for
that the two graph, do you need to draw the two graph?
yes
You mean these two graph, is it, do you need to draw it?
for each question number 1 to number 5.
Okay, for question 1 to number 5, do you need to draw the graph? Is that what you're asking?
Yes.
Okay, not necessary. Okay, it's not a compulsory that you must draw all this graph. Okay, if you don't know how to draw it, or you think you don't need it to find the final answer, okay, then you can skip it. Okay,
Okay. Okay.
so I draw it for you to know what I'm writing, right? Because if I don't draw it, then you may, okay, some students may find, how to get all these values. Okay, so I'm drawing for your reference. Okay, if any one of you you don't know how to draw it or you think you don't need it, then you can skip it. So same for the last questions. If you don't want to draw the graph, it's fine, okay, as long as you know how to solve the questions. Okay, any other questions?
In question 5, I have to say any word to explain about J, or I just do like this.
You just do like this. How do you do it?
J 0.1 yes, I just do like this, or I have explain why it's like this.
You mean you don't explain what? Can you get the same answer?
Do I have a explain, or I just write a number?
Yeah, yes, you can just write the numbers. Okay, if you can write this part, okay, until getting the final answer, then you'll get the full marks really. Yeah, you don't have to explain anything if you can write like this.
Thank you.
Okay, you don't have to write any words, explain. Okay, from a table, I got 1.282, 10% you get 1.282. No, okay, no need to write all this. Okay. All right, we will continue to the next questions. Question 10, yeah. So basically 9, 10, 11, and 12, they are very similar. Okay, all of them are normal distributions. Questions, huh? Okay, let's look at question 10. Okay, the average starting salary for new college graduates in computer information system is 47,500. Okay, assume the salary are normally distributed with a standard deviations 4,500. Okay, find the following probabilities. So the starting salary is our X now. Okay, is our X, is our continuous variable. So X, okay, the salary follow normal distributions with mean for the 7,500. Okay, variance, remember when you write in this format, okay, we are always writing the variance, not the standard deviations. So we need to square the values, 4,500. Okay, question 1, what are we looking for? Probability that the salary in excess of 55,000. So in excess means more than 55,000. Okay, so convert it to Z. Okay, let me show you for one last time. Okay, take the X value given minus the mean divided by the standard deviations. Okay, Z is more than -1. Okay, so okay, we want to find probability. Sorry, it should be okay. Left hand side -1. We're gonna find more than -5. This is sorry, it's not -1. I thought I look at the wrong. It should be 1.67. -1 is the previous question. It's 1.67. Then my graph is wrong. Okay. Mean is always 0, so 1.67. Okay, you're gonna find this part. So take 1 minus the probability less than 1.67. Okay, from the statistical table, you got 0.9525. Okay, this area. Okay, look at the second page where your Z value is positive. You should get 0.9525. Okay, 0.0475. Okay, question 2, between 45 and 52,000. Okay, so convert both to Z, you will get negative 0.56 and 1. Okay, so whenever you convert to Z value, okay, leave your answer in 2 decimals. Let's say if you have more than 2 decimals, okay, round off to the nearest 2 decimal. Because if you check the statistical table, it only tells you up to 2 decimals. Okay, the columns are, this is the second decimal. Okay, so if you, let's say you want to find negative 2.612, no, we cannot. 2.612, we cannot. We can only have up to negative 2.61. Okay, the third decimals we don't have. We can't find it from the table. So always round off to 2 decimals, right? Okay, so here, okay, let's skip the tables. Sorry, not skip the table, skip the graph. Okay, so if you want, you can, if you need, then let me know, then I will draw the graph for you. If not, then I will just write down in equations. So we are taking less than 1 minus less than negative 0.56. So 0.8413 minus 0.2877. Okay, question 3. Probability that the mean. Okay, this questions is chapter 7. Okay. Question 3, what's so special about question 3 is you want to find the probability for the mean salary, okay, of a group of hundreds new graduates. Okay, you want to find the mean salary for a group of people. Whereas for question 1 and 2, right? Okay, question 1 and 2 is you are looking for the probability for a new graduates only, the salary for one people. Okay, so you'll use X. Okay, that's why you use X. Okay, for one graduate. But how if you have a group of people? Okay, you want to find the mean salary. So we will use X bar. Okay, we want to find the mean salary, which is X bar. So this is the chapter 7 sampling distribution chapters. Okay, so put a note here. Okay, if let's say X follow normal distributions with mean and variance given is this, right? And if you want to find the probability for the mean, okay, it will also follow normal distributions with mean is the same, but the variance is now divided by n. Okay, so this is the sampling distributions for the sample mean. So how if you want to convert to Z value for normal distributions, we minus mean divided by standard deviations. Okay, for sample mean, we will take the sample mean minus the population mean divided by sigma over square root n. Okay, this is how we convert sample mean to Z value. Okay, so please take note of this. So for these questions, our X bar is the sample mean. Okay, so sample mean, it will follow normal distributions with the population mean same as what is given. Okay, 47,500. Okay, how about the variance? The variance over this population's variance over n. You will have what 4,500 square over n. Okay, sample size is 100. Okay, so this is the sampling distributions for the sample mean salary. Okay, so you want to find that the mean salary is what? Exceeds 48,000, so more than 48,000. Okay, so convert it to Z using the second formula because you want to find the sample mean, not just the X, not just the salary for one graduate. So we take 48,000 minus the mean divided by 4,500 over square root n. N is hundreds. Okay, so a bit different here. Okay, what is the Z value then? The Z value should get 1.11. Okay, so you're gonna find Z more than 1.11, so take 1 minus the probability less than 1.11. Okay, this one you refer to the statistical table. Okay, then you will get the answers. 0.1335. Okay, any questions? But this is chapter 7. Okay. Okay, no questions here. Okay, look at question 4. Okay, question 4 is what? It was found that top 5% of the graduates have the starting salary of minimum X. Find the values of X. Okay. So this one requires a bit illustrations again. Okay, maybe I will write beside here. Question 4. Okay, top 5%, is it? Yeah, top 5% graduates have a salary minimum X. So if you look at our salary distributions, okay, we know that the mean is 47,500. So top 5% means they have the salary more than the mean. Okay, so this is our top 5%. Okay, they have the salary more than the other 95%. Okay, and then you want to find this X value. This is the minimum salary for the top 5%. Okay, it could be, let's say 50,000. Minimum salary for the top 5% is 50,000. It could be 50, 51, 52,000, and so on. Okay, as long as it's more than 50,000. So we're going to find this X value. Okay, so let's write down the first steps is, because right now we have 2x, so X more than, okay, let's see, I use X, okay, I use a different color, okay, because or else you guys may confuse. Okay, this X, we're going to find X more than X here. Okay, is 5%, 0.05. Okay, then we convert it to Z. Okay, we convert to Z, you have Z more than, okay, we take this X value, we minus the mean 47,500 divided by the standard deviations, 4,500. Okay, equals to 0.05. So which means, okay, if I draw the graph for the Z distributions after we convert to Z, yeah. Okay, the mean will be 0. Okay, the line here, this is still top 5%, but my Z value, it will be X. Okay, minus the mean 47570 divided by 4,500. Okay, so Z more than, this is actually our Z value. Okay, so more than this Z value is 5%. So again, we have to refer to the statistical table. Okay, according to my methods, I will look at T distributions table. Okay, what is the area now? Area is should be 5%. Okay, 0.05. You go all the way down, you look at this. Okay, 1.645. Okay, 1.645 is the Z value for 5%. Okay, so which means here, okay, Z more than 1.645 is 0.05. Okay, if the area is on the right side, then positive Z value, okay, positive 1.645. So these two, they are equal, right? Okay, they are equal. So X minus 47,500 equals to 1.645. So solve these equations, find where is the X value. So you get 54,902.5. Okay. Any questions? So the minimum salary for these top 5% graduates is 54,902.5 dollars. Okay, is that okay? Can you guys follow, understand?
Okay.
Can, huh? So let's move on to the next questions. Okay, question 11. Okay, the quality of the electric light bulbs is measured by the lifetimes of the in hours, the longer the lifetime of the bulbs, the better is the quality. So lifetime follow normal distributions with mean 1,000 hours, and then standard deviation is 100 hours. Okay, find the following probabilities. Okay, do you guys want to try it first, and then we discuss the answers, or we can do it together for these questions? Have you tried? Okay, or maybe I'll let you try question 12 later. Okay, I'll do it one more questions for you. Okay, question 11. Okay, so what is the variable here that we are measuring? The lifetime. X is the lifetime of light bulbs. So the lifetimes follow normal distributions with mean 1,000 hours. Okay, variance would be 100 squared. Okay, so find the probability, okay, that a randomly selected light bulb has a lifetime between 900 and, okay, this is for one light bulb, so you will use X, not X bar. X bar when you want to find the probability for a sample mean, okay, for a group of items of people or people. Okay, right now you don't have a group of light bulbs, right? Just one. Okay, convert both to Z value. What would you get? -1 and 0.5. Okay, -1 and 0.5. So, okay, how to calculate the probability between these two values? You take the larger probability, okay, the Z values 0.5, less than 0.5, minus the Z value less than -1. Okay, refer this to one is positive, one is negative, yeah? Okay, so you got 0.6915. Okay, let me know if you still do not know how to read the probability from the table. Okay. Oh. Okay, I don't draw the graph. I don't show you how to find already. Yeah. Okay, by now, just now I've shown you, right? Okay, if you still don't understand that, then let me know. Okay, so this is answers for first questions. How about second questions? The light bulbs will have a lifetime of less than 900. Okay, less than 900. Okay, convert to Z, you take 900 minus 1,000, divide by 100. Okay, you will get -1. So this one, very straightforward, refer to the negative value table. Okay, same as the first question, 0.1587. Okay, question 3. Okay, find the maximum lifetime of the bottom 5%. Of the bottom 5%. Okay, this time we are looking at bottom 5% of the worst quality. Okay, so we are looking at the worst, meaning they will have the lifetime less than the mean. Okay, on average, they have the lifetime 1000, but this is the worst quality one. Okay, the worst. That means they will have a shorter lifetime. So when we look at the lifetime distributions, so the worst quality should have less than the mean. Mean is 1000. So your worst quality should be on the left hand side. Here, this is the worst quality, the worst 10%, is it? Sorry, 5%. Okay, the worst quality, the bottom 5% of the light bulbs. Okay, so let's say you want to find this A value. Okay, how do you write it? Okay, you will first write probability x less than A is 0.05. Okay, next, okay, you will convert it to Z. Okay, you have Z less than A minus the mean. What is the standard deviations? Hundreds. Okay. Then divided by, okay, hundreds equals to 0.05. So if you convert this to the Z distributions, mean you have 0. Here, C, 5%. You got this A minus 1000 divided by 100. Okay, so where is the Z value for 5%? Okay, here 5% just now, same as the previous questions, 1.645. Okay, but 1.645 is for the area in the rectangle. Okay, right now our area is in the left. Okay, in the left tail, yeah. So this would be equals to negative 1.645. Okay, you have to add a negative yourself. Huh? Okay, if the area is on in the right tail, then you use 1.645. But now it's in the left tail. Okay, so which means probability Z less than negative 1.645 is 5%. Okay, so these two, you let them to be equal, then you will get the answers for A. Okay, answers will be, okay, 835.5. So the maximum lifetime for the worst 5% light bulbs, the maximum is 835.5. So they will have the lifetime less than or equals to 835.5 hours. Okay, any questions? Oh, 3:14. I think we will take a short break. Okay, a quick break, 10 minutes. Okay, I think, yeah, let's take a break lah. If we straight away continue to 4 p.m., that will be quite long already. Okay, let's take a break. Okay, if you have nothing to do or what, okay, take these 10 minutes, you solve question 12. Okay, later we discuss, come back with question 12. So take a 10 minutes break. Come back at 2:25 p.m. Wait, no. Okay, I'll see you after 10 minutes. Okay. All right. Is everyone back? Have you done the question 12? Or is anyone still doing it? Do you need me to wait for you to finish? Okay, so let's look at question 12. Okay, the weight of the soap bar is normally distributed with mean 2000 grams with a standard deviation of 20 grams. Okay, so what is the probability that a randomly selected soap bar will weigh between 1990 grams and 2030 grams? Huh? Okay, so let's write down the question 12. Okay, X is the weight of the soap bar. Okay, so it follows normal distributions with mean. Mean equals to 2000 and then standard deviation is 20. Okay, so question 1. Between 1990, okay, you want to find X between 1990 and 2030. Okay, so convert both values to Z. Okay, what did you get? Okay, you will get a negative 0.5 and 1.5. Okay, so take the probability less than 1.5 minus the probability less than negative 0.5. Okay. Correct. Okay, let's calculate what's the answer. Okay, all right, do you guys get the same answer?
Yes.
Yes. Okay, great. Okay, question 2. Okay, the probability that the randomist soap bar will weigh more than 2020. Okay, so find the probability X more than 2020. Okay, so convert to Z, you get 1. Okay, you want to find probability more than 1. So take 1 minus the area less than 1. Okay, so 1 minus 0.8413. Okay, 0.1587. Okay. Question 3. Okay, question 3 is the probability for the random, of a sample mean of random sample of 50 bars. So this is the sample mean weight. Okay, for these questions, you're looking for the probability for the sample mean weight. Okay, will be weighed more than 1995 grams. So this is our sampling distributions questions. We're going to find a sample mean weight for a group of 50 soap bars. Okay, so for these questions, the mean weight, okay, the X bar, okay, write down the distributions for the X bar. Okay, the mean would be equals to the same 2000. How about the variance? Okay, variance over n, it will be 20 square over sample size is 50. Okay, so you want to find the probability that the sample mean is more than 1995. Correct. Yeah. Okay, so this one, remember when you convert to Z, don't just divide by alpha. Okay, 1995 minus the mean, but alpha over square root n, because you're looking for the probability for the sample mean. Okay, for a group of items here. Okay, so you got Z more than negative 1.77. So take 1 minus less than negative 1.77. So 1 minus 0.0384, you get the final answer. Okay, 9616. Okay, any questions? Okay, we have done all the probability questions, module 2. Is there anything you'd like to ask? Okay, so we still have some time. Maybe we can do maybe the first 2 questions. Then we will call it for a day. And the rest we continue tomorrow. Is that okay?
Yes.
Yes, sir?
Yes, okay.
Okay. Okay, I hope you guys won't feel too tired, huh? Okay. Okay, all right. So, yep, let's start module 3. Okay, module 3 mainly is chapter 7, 8, and 9. Okay, but chapter 7, I put it under module 2 questions already. So this module 3 questions, it focus on chapter 8 and 9. Okay, the estimation chapters and the hypothesis testing chapters. Okay, hypothesis testing is the one, okay, very headache, right? Okay, so let's look at the estimation first. Okay, so for estimations, let's look at the formulas. Okay, maybe it will be better if I look at the formulas. Okay, estimations. Okay, for estimations, we have these 3 formulas. Okay, we have the interval point estimations and interval estimations. So under estimations, we will use these 3 formulas to calculate the confidence interval. Okay, so the first 2 formulas is for to calculate the interval for population mean. The third formula is for population's proportions. Okay, so notice there is a difference in the first 2 formulas. One is using Z, one is using T. Okay, and then when we are using Z, we use population's standard deviation. So this sigma is the population's standard deviations. So the first case is if we know the population standard deviations, meaning if the question tells us the population standard deviations, the value, then we use the first formula. If we don't know the population standard deviations, then in the formulas, we will use the sample standard deviations. Okay, instead of sigma, we use S. Okay, so the second formula is using T distributions. The first one is using Z. So these are the differences. And then for proportions, there is only one formula. Okay, the P hat is the sample proportions. Okay, X bar you guys know already, right? Sample mean. So P hat, okay, P hat is sample proportions. Okay, how about Q? Q hat is 1 minus P hat. Okay, you can think of this P and Q like the binomial, probability of success and probability of failures. No? Okay, so here sample proportion is P hat, so Q hat is 1 minus P hat. Okay, so basically these are the three formulas that we use when we want to find the interval. Okay, depends on the questions and what are the informations we have. Okay, so let's read the first questions. Okay, police department would like to estimate the average speeds of car passing along a stretch of highway by installing a speed detectors. Okay, from a random sample of 30 cars selected, okay, found that the sample mean was, the mean speed was 110 kilograms, sorry, not kilograms, kilometers per hour. Okay, assuming that the population standard deviations is 10 km per hour. All right, then, okay, find and interpret 95% confidence interval for the true mean speeds of car passing along this stretch of highway. So that means if where is the mean speed for all the cars, okay, passing along the highway? Okay, so we want to estimate the population mean, okay, by finding the interval. Okay, so here, which formulas do we use? Do we use the Z formulas or the P formulas? Okay, the mean is equals to, okay, let's write down the Z formulas again. Okay, then times is sigma O square n. Okay, this is the second formula. Oh no, we don't use sigma, we use S. Okay, which formulas do we use? Okay, we look at the questions. We have the sample size. This is the N. We have the sample mean. This is the X bar. Okay, population standard deviations given. This is 10. Okay, so right now we have the sigma given, right? Population standard deviations. So we use the first formula. Okay, that's how we determine it. If we know the population standard deviations values, then we use the first formula. Okay. So a 95% confidence interval for the mean is equals to, let's apply the formula, substitute the values inside. Okay, X bar is 110. Then, okay, Z value. Okay, this is another thing. How do we find the Z value? What is the alpha here means? Okay, so if you are looking for a 90% confidence interval, then your alpha, it would be 5%. Okay, so let me illustrate it with the graph here. Okay, so the questions will tell you where is the confidence interval. Okay, if the middle is 95%, okay, so what is the remaining amount? 5%, right? Because the total graph, the total area is 100%. So if in the middle, we already have 95%, okay, this is what we want to estimate. So the remaining area, it will be 5%. So this 5% is the chance that we make the wrong estimations. Okay, so that means the population mean is outside the interval that we found. Okay, so the remaining percentage is 5%. So when we divide it by 2, alpha over 2, you got 2.5% left. So we are looking for this Z 0.025. Okay, so we are looking for this Z 0.025. So here is, this is actually Z alpha over 2 is 2.5%, which is 0.025. Okay, so how do we find this value? We have to again remember just now in the normal distributions questions, how do we find the Z value? We look at the T distributions table. Okay, we look for the area. Okay, right now the area is 2.5%. So, okay, we look at 0.025. We go all the way down. Okay, so the Z value is 1.96. Okay, it's 1.96, which means, okay, here this value is 1.96. Okay, let me erase this out. So Z alpha over 2, it will be 1.96. So the alpha over 2 is the area in the left and the right field. This is alpha over 2. This is alpha over 2. Okay, then you add up the whole area, you get 100%. Okay, so 1.96. So how if, okay, let's say you want to find 90% confidence interval. If the area in the middle is 90%. How? So what is the remaining area? The remaining area is 10%. Okay, and then when you divide by 2, you got 5% on each side. Okay, on each side. So where's the Z value then? Okay, Z value for 5%, just now we have been using this. Okay, 1.645, yeah? Okay, that area is 0.05, 5%, 1.645. So here, 1.645. So you look at the interval that we want to find. Okay, sometimes it could be 95%, sometimes it could be 90%, 99%. So you read the questions and find the Z value from the statistical table. Okay, so back to these questions. We want to find 95%, right? Okay, so here we take the sample mean plus minus the Z value. Here we use 1.96. Okay, 95% confidence interval. Then multiply by the population standard deviations, which is 10. Divide by square root sample size is 30. You have collected 30 cars. Okay, solve these. Okay, solve these equations. Okay, you have, okay, on the left, you must minus, okay, the smaller values you put it on the left. So minus, and then on the right side, you put your plus, the largest value. Okay, so write your answers, put it in brackets. Okay, so this would be your answers. Okay, 106 and 113. So what does it mean? Okay, so this is find the interval only. Okay, you haven't interpreted. So what does it mean by this answer? Okay, so which means we are 95% confident that the true mean speed. What is true mean speed here? This means the population mean speed. Okay, the true mean speed for the whole populations, for all the cars. Okay, the true mean speeds of the cars. Okay, passing. You can copy the questions. Okay, the true mean speed of cars passing along the stretch of highways. Okay, passing along the highways. Yeah, typo. Okay, highway. Okay, is between. Okay, between the answers that we found. Okay, 106.42 kilometer per hour and 113.58 kilometer per hour. Okay, so that means we are 95% confident that the population mean speed is between these two values. Okay, we are 95% sure. Okay, how about the remaining percent? Okay, so there may be a remaining 5% chance that the mean speed, the population mean speed is less than 106 or more than 113. Okay, so this is 106.42. Okay, so we are sure that somewhere around between these two values, it lies the population mean. Okay, 95% confidence. But there is also 5% chance, okay, that the population mean is less than 106 or more than 113. There is a 5% chance, okay? So that we will make the wrong estimations. Okay, that's the meaning of finding this interval. Okay, you want to estimate the population mean. Yeah? Okay, any questions?
How I can know about 1.86?
How can you know about what point?
1.96.
1.96. Okay. So 1.96, how do you find it? You just now say this right. So you look at the t distribution table. Okay, there are 2 pages. Go to the second page. Okay, the last page. Okay, you look at the top. Okay, the area in the rectangle. Area in the rectangle means this right? This is the area in the rectangle. Okay, what is the area in the rectangle that we are looking for now? 2.5%. How do I know 2.5%? Look at this graph. Okay, when I have 95%, okay, when I have 95% confidence interval, meaning the area in the middle is 95%. So alpha is the remaining area. Okay, if the middle is 95% already, so remaining area is 5%. Okay, and then this 5%, it will be shared by left and right side. Okay, so you have to divide by 2, and then that's how you get 2.5% on each side. Okay, so left hand side is 2.5%, right hand side is 2.5%. So the Z value here, this is the Z alpha over 2, which is Z. This is Z 0.025, okay, for 2.5%. Do you understand how to get 1.96?
I'm not sure about 5%.
The 5%, okay. do you need me to draw it bigger? Okay. First you need to understand whole area. The whole area is 100%. Okay, you cannot be saying that, oh, my whole area is 150. No. Okay, the whole area is the total probability. Okay, 100%, 1. So when the question is asking for 95%, meaning, okay, you want to find this interval A and B. Let's say this A and B is what we found, 106 and 103.58. But let's say this is just A and B values, okay, in general. So we want to find this interval that contain the population mean, and we are 95% sure that the population mean, okay, is between these A and B values. And questions will always tells us this percentage. So this percentage is not always 95%. Okay, it could be any percentage. Okay, 90%, 95%, 99%. Okay, doesn't matter. So, okay, with the given percentage, then we need to know what is the remaining area here. Okay, let's see these shaded areas. What is the remaining percentage? If my middle, my center is 95% already, you tell me where is my purple shaded areas here? What should it be? The value area.
5%.
5%? Yes. Okay. The total, when you add up these two purple color area, it should be 5%, right? Okay, the total, not for one side. So how if I look at only one side, okay, if I only look at the left hand side, it will be 2.5, and right side is also 2.5. That's how I get 5%, isn't it? So, yeah, right?
I clear.
Yeah, so that's how we get the 5% first. Alpha is the remaining area. Okay, combining both left and right, 5%. So alpha over 2 is the remaining area, or I should say this is the total remaining area. Okay, this is the total, yeah, wrong, different color. Okay, total remaining area. But the alpha over 2 is the remaining area in either left or right side, right here. Okay, one side is 2.5, another one is 2.5. So using this, we can find the Z values already. So let's say if this is 2.5%, what is the Z value for 2.5%? Or normally I will just write 0.025. I don't write 2.5%. Okay, I'll convert to decimals. So 2.5%, I get 1.96. Okay, so here this value is 1.96. That's how I get my Z value. Okay, are you guys clear?
Yes, I'm clear.
Okay, okay.
All right. Okay, Kenna. So make sure you understand this because when we go to chapter 9 hypothesis testing, we will be using the same Z or T values. Okay, so you need to understand the alpha over 2, okay, and then how to find the Z value. Can okay, I think let's finish off question B, then we'll stop here already. Okay, question B. What is the minimum sample size so that the sampling error at 95% confidence level does not exceed 2 km per hour? Okay, so this is to find the sample size. Okay, the minimum sample size that you should collect. So refer back to the formula sheets. Okay, so below the confidence interval, you see two formulas for this to calculate the sample size. Okay, the first formula is for population mean, to calculate sample size for the population mean. The second formula is for proportions. Yeah? Okay, so let's look at these two formulas. Okay, so Z value is how you find it when you want to find the confidence interval just now. Okay, you will substitute the Z values inside this formula. Sigma is the population standard deviations given. Okay, then this E. This E is called the margin error or the sampling error. Okay, what is this E actually is about? Which means, okay, let's look at the graph again. So just now we say the center is always the mean, right? Okay, we want to find the A and B value. And then we have, let's say this is 95%. Okay, let's say this is 95%. Okay, what is the E here? E is actually, okay, this part. This is the E. Okay, this is the sampling error, which is actually Z times the standard deviations over square root n. Okay, E is equals to this, and it is called margin of error. So when you want to find the sample size, right, questions will always tells you the margin of error or the sampling error. Okay, the E value. So back to these questions. Yep. Okay, scroll it back up. Yeah, this one. Okay, so what informations do we have here? Okay, we know the sample size. Okay, we don't use 30 anymore. Okay, we want to find a minimum sample size so that the margin of error or the sampling error does not exceed 2. Okay, at what percentage? 95%. So we can use the same Z value. Okay, we can use the same Z values as question A. We look for Z 0.025. Okay, we will use this value for question B because the percentage is the same. Okay, 95%. So let's write down the formulas first, since this is the first time we do it. So n is equals to Z alpha over 2 times the population standard deviations divided by the sampling error square. So basically this one very simple. You just substitute the values given. Okay, so Z value is what you need to find from the statistical table. Okay, then population standard deviation is given is equals to 10, right? 10. Okay, divided by sampling error. Sampling error here is 2. You don't want to exceed 2 km per hour. Okay, you don't want to exceed 2 km per hour and then you square it. Okay, so what is the answers you get? 96.04. Okay, 96.04. Okay, and then please take note. Okay, put a note beside here. Whenever you want to find the minimum sample size, right? Okay, because this is a minimum sample size. Okay, minimum is 96.04. So how much should you collect? Okay, the samples. Okay, because when we collect sample, okay, whether is it object or people, we cannot have decimal. How can you collect 0.04 cars? You cannot have 0.04 cars now, right? So here we will always round up, okay, to the nearest integers. Okay, so your final answer is 97. So you should collect 97 cars as your sample. Okay, 97 cars. Okay, regardless of the decimal, even you get 0.04 or 0.01, you will always round up. Okay, unless you get 95 point something, then you round up to 96. Okay, any questions? Okay, we will stop here. No? Okay, we will stop here for today. Let me know if you have any questions. Let me know now. If not, I will just stop here and then I will see you guys again tomorrow. And then we'll continue with question 2.
Yes.
Okay, no questions? All right. Okay, then